Hey buddies, my name is Sibusiso, but you can also call me Coach Sbu. Welcome into the Maths Buddies tutorials. In this video, we're going to be going through our third video of the grade 11 March exam preparation, right? So now in the previous two videos, we covered Euclidean geometry and a little bit of algebra. And then now we're going to be going through trigonometry. Now this trigonometry is for both grade 11 and grade 12. So before we start, please make sure that you share this video with your friends. Make sure that they get hold of this, and then also make sure that you stay tuned by subscribing, and also leave a comment and tell me what you think about this video. All right, so another thing is to also make sure that you stick to all the videos that I've given you, and if there's anything that you would like for me to do, make sure that you share that on the comments so that I can be able to generate that video for you. All right, so now here we're going to be going straight with the first one, which is the trigonometry. We would like to simplify the following question without the use of a calculator. Now, whenever you see something like this into trigonometry, just know that it is just there to limit your mind, because most of the people, when they see this, they just leave the calculator away. But then with trigonometry, if you have something like this with numbers, it means now you actually need to press this on your calculator, right? Because these are just numbers. So the first thing that you always need to do when you're given something like this, where they want you to simplify, is to actually press it on your calculator. So let's go ahead and do that, right? So now the first thing is I'm going to press that on my calculator. 10205 multiplied by cos 315, and then multiply by sine 135. I'm going to try and move as fast as I can with this one, because we just type in this, times cos 150, and then times tan 25. Now let's see what we get. So we're getting 1,155. So it means 1,155 is something that I'm trying to get into, right? So now that I know what I'm trying to get into, it means I can now go into my question. Now, going to my question, first thing that I need to do here is to first write the question as it is. It is to check if I have any angle that is above 360, and also if I have any angle that is negative here, right? So now the idea is that if you have an angle that is above 360, you need to subtract that angle up until it becomes an angle that is actually below 360. And then if you have an angle that is negative, you need to add 360 there up until you're left with an angle that is greater than 0, or that is positive but still less than 360. Now in this case here, we see that the only problem that we have is that we have this negative angle here. So which means now I'm just going to take out my calculator, and I'm going to write that angle, and then I'm going to add 360. So it gives me 210. So what am I going to do here? So the first thing that you're going to do is to write everything out. 10205 times cos 315 times sine 135. But then now here you change that minus 150 into that 210 you just got. Now you're going to lose a mark here. No, you're getting a mark actually by doing that, because the teachers know that here you actually showed that you were you basically simplify that into that, right? It's the same thing. Press this on the calculator and press it on the calculator, you're going to get the same answer. All right, then now from there, what we're going to do now is we're going to apply reductions. Now with the reductions, I want you to understand that reductions, there are only 4 things that you need to do, or there are 4 type of reductions that you need to apply, right? So these 4 reductions, I'm just going to try and list them here so I can help you understand it. So firstly, we know that here, first quadrant, all trig ratios are positive. Sine is positive there, tan is positive there, and then cos is positive there, right? So now the first trig ratios, we know that the first one, reduction here, it is 360 plus theta. This one is 180 minus theta, 180 plus theta, and 360 minus theta. So these are the very first reductions that can help you out a lot, right? Now we also know, just to make sure that I keep it there, also know that this is 90, 180, 270, 360. Notice that I didn't write 0 there. I didn't say 0 and 360, and the reason for that is because when we simplify this, our aim is to reduce any angle that is more than 90 and keep it into an angle that is going to be between 0 and 90. So now Here, what I'm going to do is we're going to be actually now reducing these values. So how do we reduce them? Very simple. So this is what we do. So here, the idea is that the first thing that you always need to do is when you look at the number, you're going to ask yourself between which two numbers can you find this number? For example, 205. Between which two numbers can I find 205? I can see that 205, I can find it between 180 and 270. So what does this mean? So this means now I can take this 205 and write it according to this reduction. So how do I do that? So this is how we do it. So you first start by writing the reduction 180 plus. So now you're going to ask yourself, what number do I need to add 180 with to get 205? And of course here is going to be 25. Then now we're going to do the same thing with the second one. 315 is between 270 and 360, which means I need to use this reduction to write 315. So now this is going to be 360 minus. So what number do I need to subtract 360 with to get 315? And then of course it is going to be 45. Then I have sine, and then I'm going to 135. 135 is between 90 and 180. So it means I'm going to be writing that reduction as 180 minus. So what number do I need to subtract 180 with to get 135? It is going to be 45. So I'm going to then go into at the bottom or the denominator. Then now here I have sine. Now I have 210. 210 is between 180 and 270, which means we're going to be using 180 plus. Now what number do I add 180 with to get 210? I'm adding 30. All right. And then 150 is between 90 and 180. So which means I'm going to be using 180 minus. What number do I subtract 180 with? It is 30, which will give me 150. But what about 1025? 1025 is already below 90, so which means I'm going to keep it as that. Now, everything now is written as what? Is reduction. Now, please make sure before you proceed here is that you check if this number, when you add them in your calculator, does it still give you 205? Does this one still give you 315? Does it still give you 135? Does it still give you 210? Does it still give you 150? Because you don't want to make a mistake by changing that, because if you do, then it means everything else will be completely wrong. All right, so now next step here is we have written everything in the reduction, so we're just going to be asking that this reduction, this trig ratio, is a positive or is it negative. So 180 third quadrant is 10 positive there, so it is positive, so it means I'm going to write it as 1025, right? Then now 260 minus fourth quadrant is cos positive there, yes, so I'm going to write it as cos 45. 180 minus second quadrant is sine positive there, yes, so I'm going to write it as sine 45. Then over, then here 180 plus third quadrant is sine positive there, no, it is negative, so I'm going to write it as negative sine 30. 180 minus second quadrant is cos positive there, no, so I'm going to write it as negative cos 30 times 1025. Now notice here that everything has been reduced and all the angles are between 0 and 90. Then now here it's just going to be used simplifying, right? Now how do we simplify? I can see that here the numerator and the denominator is one term, right? So the reason why I'm cancelling here is because here this is one term, because this is just a product. The numerator, they're all multiplying each other, then the denominator, they're all multiplying each other. So when it's one product and one product at the bottom, it means you are allowed to cancel. Please do not cancel when you still have two products there. Sorry, two terms and three terms maybe there, right? Do not do that. Always stick to cancelling only when it's one term and one term. So cancelling that, it leaves me with cos 45, right, times sine 45 over, then now here I have those negative there, so I'm going to multiply each other. Negative times negative, they give me positive, so I have sine 30 times cos 30. Now when you get here, these are special angles, right? So special angles are the angles, let me just write there. Special angles, it is angle 30, 45, and 60. So we call these ones special angles. Even 90 we call it, and even 0 we call it special angle. So I can just add those ones, but we like to stick with these three here, right? Because these are the ones that can actually form the angle there, the triangle there. Now with these ones, the idea is that when you were taught in your class, in your school, or by your teacher, you were told that you're supposed to actually use the triangles, right? But then now for me, I don't think you need to actually use the triangle. You can actually use your calculator. Then now, how do you use the calculator? So this is how. Now basically what you're going to do is you're going to press each trig ratio on your calculator. Now for example, cos 45. So if I press cos 45, this is what I'm going to get. Now if your answer is like this, so what is this? Here I have a square root 2 over 2. See here I have a square root, and then there's a number 2 here, and then there's the same number is here as a denominator. So if I have this, then this means the calculator has rationalized this. So what does this mean? So it means now I need to change this and write it as 1 over root 2, right? Because this is what you're going to be getting on your triangle, right? See here, same thing. So it means now when I see root 2 over 2, I'm going to write it as 1 over root 2, right? Whenever you see root 2 over 2, always write it as 1 over root 2. And then let's see sine 45. See what does sine 45 give us? Root 2 over 2. So it means, of course, it is 1 over root 2, right? So it's only, I think it's only root 2 over 2 and root 3 over 3, where you change them into 1 over root 2 and 1 over root 3. Other things that you press on the calculator, you write them as they are, right? So here, for example, I have sine 30 and get 1 over 2. Sorry, sine 30 getting 1 over 2. So it means I'm going to write it as 1 over 2. And then cos 30, I'm writing it as root 3 over 2. See, I'm not changing that. So it's not about the square root, it's about whether it is rationalized or not, right? And then from here, you're just going to multiply the top alone and the bottom alone, right? So here, proceed with a calculator, just for the purpose of the video, so that you can see that I am not talking my thing there. So 1 over 2 over, and then this one is going to be, of course, root 3 over 4. And then from here, you will then separate these two fractions like that, right? And then when you separate them like that, it means now you can keep this, change the division into multiply, and then swap that one there. And then you can see that now the 4 can cancel that, leaving 2 there and leaving 1. And then 1 times 2, of course, it is going to be 2. And then 1 times root 3 is going to be root 3, right? So if you then rationalize your denominator there, this will be then 2 root 3 over 3, right? And then that's going to be your answer. Now remember, you're done now, right? So you want to see if your answer is correct. So let me just leave this one. Let me just write it here, right? Just leave it like that, right? Okay, so now you have your answer there. So now you can then go to your calculator and press that 2 over root 3 and see what we get. We get 2 root 3 over 3, fine, but we're getting 1,155. So it means we are correct. Okay, so now let's go ahead and look into the second one. So the second one, it is proving the identities. So when you prove the identity, it's very important to do this. Proving the identities, it is all about making the left hand side equal to the right hand side. Now there are 3 things, right? You can either get a question where the left hand side is the one that you need to simplify that, and then it gives you exactly the right hand side. Or secondly, you can get an equation where the right hand side is the one that you need to simplify, and then when you simplify it, it gives you exactly the left hand side. And then finally, which is the one that they'd like to give it to you, is when you simplify the left, you can't see which one you need to simplify, right? And then you simplify the left hand side, and then you see that when you simplify the left hand side, it gives you an answer that is not the one that is on the right hand side. Now that doesn't mean that it is incorrect. What that means is that you need to just take the right hand side and simplify that one also, and then see what you're gonna get after, right? So let's go ahead and look into this one. So with this one here, I'm just gonna look at this one, and then I'm just gonna see which one I'm gonna take here. I can see that it's difficult for me to pick up which one to pick here. So it means now here, this is my hint, or this is a hint that I need to simplify both of them, right? So I'll start with the left hand side. So it is that over 10 squared x times cos squared x. Now when you're dealing with identity, it's very important to actually have steps. Now the very first step that you always need to do here is that if you have 10, always change it to sine over cos. So here we have 10 squared, so which means now the very first thing that I'm going to do here is to change that into sine squared x over cos squared x times cos squared x. Now notice that by writing this fraction, this is a numerator, right? This is a denominator, right? Now because of that, I can then cancel this with that, right? Then now what do I get here? Let's see. When I cancel there, I'm getting minus 1 over sine squared x, right? So this is the only thing that I can get into, and then this is where I am, right? Now, is this answer the one that is on the right? No, it is not. So does that mean that my answer is incorrect? No, it doesn't mean that. It means that I just need to take the right hand side. Now with this one, I can actually continue by writing it as 1 minus cos squared x. Let me just keep it like that, right? And the reason for this is because I'm seeing that I have cos there, right? But okay, let's keep it like that. Okay, so now I have 1 minus, and so now I'm going to take the right hand side. So taking the right hand side, I know I can see that I have 1 over cos x plus 1 cos x minus 1. Okay, so now here I can see that my denominator, this is a difference of 2 squared, right? In the sense that here I just need to multiply cos x times cos x, which will then give me cos squared x, and then positive times negative. Okay, let me not do it that way. Let's do it the old-fashioned way, because I don't want people now doing this in every pro that they see. So basically we're going to multiply this with that, and this with that, this with that, and that with that. Okay, so let's do that. So it is 1 over cos squared x minus cos x plus cos x minus 1, right? And then from here, this cancels with that, and then I have, let me write this on the next page, then I have 1 over cos squared x minus 1. All right, now here I can see now that this is similar to that, right? But then now here on the right hand side, this is positive, but then that one it is negative. So which means now here I just need to take out a negative factor on my denominator. So let me do that. So when I take the negative factor, this becomes negative and that becomes positive. So I'm just going to write the one that is positive in front and the one that is negative after that, right? Now this is negative 1, right? So negative 1 divided by 1, it gives me what? It gives me negative 1 over 1 minus cos squared x. Now this is the same as the left hand side, and therefore left hand side, it is the same as the right hand side. All right, so let's go ahead and look into 6.3. So this one I like to call this trigonometry in triangles, but then this one is going to be like the one that has in terms of t and all of that. All right, so how do we do this one? So the one that is in terms of a certain variable, what you do is very simple, is you need to draw a triangle, right? So here, for example, I'm given that I have cos 54 being equals to 1 over t squared, right? Now I know that this is a trig ratio, right? So because if I'm going to draw this into a triangle, I need to write this as a ratio. So cos, I know that can be adjacent over the hypotenuse. So now here, because I was given like that, my hypotenuse is going to be 1. So it means now here, I know that it's going to be my adjacent, so I'm going to call it as x. Hypotenuse is going to be my r. And then now I'm going to go and sketch my my triangle there. So my triangle is in the first quadrant, like that. Always going to be in the first quadrant when you're given numbers like that. When you're given an angle that is less than 90, it's going to be there. So okay, so here I have my 54, right? And then it said adjacent over hypotenuse. So now the first thing that I need to do here is to fill in the rest. And in my triangle, I can see that I need to find an angle here which will complete the triangle. Now how do I get that angle? Always take 90 to get that angle and subtract that the angle that you're given there. For example, here 90 minus 54 gives me 36. So here I know that I have 36. So now the only thing that I need, which is left, it is this y value. Now how do I find the y value? I'm gonna apply Pythagoras. So therefore here x squared plus y squared equals to r squared, and then x, it is root 1 minus t squared whole squared plus y squared equals to 1. So this is 1 minus t squared plus y squared equals to 1. Take this across, and then y squared equals to 1 minus 1 plus t squared. Y squared becomes t squared. Put the square root. Because if I'm putting a square root, my answer is going to be plus minus t, but then I want the one that is positive, so it's going to be t, because this is above the x-axis. So I know that here I have t. So now I can go to my question. 6.3.1, it wants me to calculate tan 54. Now how do you answer this question? So basically the idea is that this trig ratio, it must contain an angle that is either 54 or 36. Now if it doesn't do that, then you need to manipulate or change that value into a value that's gonna be that. Here 54, we can see that 54 basically it is there, so it is opposite over adjacent. So opposite, it is t over adjacent, it is root 1 minus t squared, right? Are you going to get the full marks? Yes. Why? Because you've already done this part, which they actually marked it as the 3 points, right? So 6.3.2, right? And then now we have sine 216. Now is 216 in there? No. So what does that mean? So it means we need to reduce this. Now between which quadrant do we find 216? So 216 is between 180 and 270. So that's the third quadrant. So in the third quadrant, we know that the 216 is going to be 180 plus something. So what number do we add 180 with to get 216? That is 36. So 180 plus third quadrant, is sign positive there? No, it is what? It is negative. So here it's going to be negative sine 36. Now we have 36 there. What's the opposite there? It is root 1 minus t squared, and then the hypotenuse, it is 1, right? And that basically means now we have minus 1 minus t squared, and that's going to be our answer. 6.4, it's going to be our final question. And the final question here, we're dealing with a general solution. Now general solution, you have to be really good when it comes to your algebra, because it is basically the algebra of trigonometry, if I can put it that way. So let's go ahead and look at what we have here. So we're given cos beta minus 1 over cos beta equals to 5 over 6. So they want us to solve for that. So the first things first here that I see there's a problem, it is that we have cos b as a denominator. So what we're going to do is we're going to multiply by that cos b, because we don't like our trig ratios to stay as denominators. So when we do that here, this gives us cos squared beta minus 1 equals to 5 cos beta over 6, right? Now I still have this 6 here, so I don't like that either, so I'm going to multiply there, and then this is going to give me 6 cos squared beta minus 6 equals to 5 cos beta. Now am I happy with this one? Yes, I'm very happy. I'm very pleased, by the way. So it means now here I can have my trinomial set up like that. So we have that, and that equals to 0. So now in my mind, I'm like, okay, so now we need to find factors that can give us 5, right? So now the easy way to do this is that if you cannot actually find your factors, you can simply go straight into multiplying these two, or you just use the quadratic formula, right? But for me, I can factorize this. So by factorizing this, what I need to do first is multiply this 6 and 6, So 6 times 6, I know that it gives me 36. Then now I need to find factors that can give me 36. Sorry, factors of 36 that can give me 5. Now that will be 9 times 4. Alright, so I know that that is 9 times 4. So all I have to do now from here is to write this minus 5 cos beta according to these, using these numbers here. So basically now this will then be 6 cos squared beta, and then from here this is going to be minus 9 cos beta plus 4 cos beta. See here, I wrote the minus 5 using those factors, and then I said minus 6 equals to 0. Now what does this thing do? So basically what it does is that it creates a grouping, right? So these first two terms, I'm going to take out a common factor there. So for example, the common factor there is going to be 3 cos beta, right? So if I do that, I'm left with 2 cos beta minus 3. So what about this 2 1? So these 2 1, I can see that I can take out 2 there, and then I'm going to be left with 2 cos beta minus 3 equals to 0. So now I have two terms, so that 2 cos beta minus 3 becomes the factor of those two terms. Then I'm left with 3 cos beta with the first term, and then the second term I'm left with plus 2 equals to 0. So it means here I've factorized. So the first one is going to give me cos beta equals to 3 over 2, and then the second one is going to give me cos beta as minus 2 over 3. Alright, so we have two general solutions that we need to do here. So let's start with the first one. So the first one, it is cos beta equals to 3 over 2. Now this answer, the first thing that we do is look at the nature of the answer. This answer, it is positive. So because of it is positive, it tells me that I'm going to be doing my general solution on the quadrants where cos is positive, and that will be 1 and 4, right? So now here I need to find my reference angle. So therefore the reference angle will be the inverse of 3 over 2, right, of that number there. So let's see there, press calculator. Inverse of 3 over 2, oh, that's an error, close that. Oh, we're getting an error. Oh, it makes sense because that answer is over 1. So it means now here it is an error, right? So it means there's gonna be no general solution for the first one, right? And then now we just look at the second one. So the second one, here we have cos beta now being equals to minus 2 over 3. Nature is negative. So it means quadrants where cos is negative, it is quadrant 2 and quadrant 3. Reference angle will then be cos inverse. Now notice that you're not going to put in the negative sign there. Why are we not putting the negative sign? Because we have already used it. How did we use it? It helped us to understand which quadrant to actually work on, right? So now here we're going to be doing the other way around now, 2 over 3. So we're getting 48,19. So 48,19, 48,19. And therefore, we're going to go to our general solution. So the second quadrant general solution has a reduction of 180 minus reference angle. So therefore, what we're going to do is we're going to say beta equals to 180 minus our reference angle, 48,19, plus 360k, where k is an element of integers, right? So we're gonna have that. Let me just do it like that, and then press this in a calculator. 180 minus 48.19, that will be 131.81 plus 360k, right? Then our third quadrant, it states that the reduction there is going to be 180 plus reference angle. So this is the reduction for the general solution. Beta, it is then going to be 180 plus 48.19 plus 360k, where of course k is an element of integers, and therefore b is going to be equals to, let me change that into a plus, it is going to be 228.19. 228.19 plus 360k, and that is how we end our video. And thank you so much for watching. Please make sure that you don't forget to share this with your friend, and also if you have anything that you leave on this video, please make sure that you leave that in a comment, and also share this with your friends, and don't forget to also subscribe and like, so that you can be able to actually be part of this Maths Buddies community. I'm gonna see you on to the next one. Cheers.